Synthesis of chemicals from common salt. Friends, in this video, I am discussing an important topic, namely synthesis of chemicals from common salt. You see this figure, which indicates the synthesis of hydrogen gas, chlorine gas, and NaOH by electrolysis of aqueous NaCl. You can see here the electrolyte is 26% aqueous NaCl. The anode and the cathode are graphite materials, graphite rods. And you have A is anodic compartment, C is cathodic compartment, and B is ion selective membrane. The function of ion selective membrane is to allow only sodium ions from anodic compartment to cathodic compartment. It does not allow hydroxyl ions or chloride ions from cathodic compartment to anodic compartment. When you supply current to the cell, there is evolution of hydrogen gas at cathode, evolution of chlorine gas at anode, and then aqueous sodium hydroxide collected from the cathodic compartment. See, the same thing is explained in this slide also. Now, electrochemical reactions at higher concentration of NaCl, such as 26% NaCl aqueous, the following reactions occur. At anode, 2Cl minus gives rise to Cl2 gas plus 2 electrons. At cathode, 2H2O plus 2 electrons gives rise to H2 gas plus 2OH minus. Note, as the electron potential of H2O is much greater than that of Na plus, the equation 2 occurs at cathode, but not the reduction of Na plus. The OH ions react with Na plus ions and form NaOH in the cathode compartment. The reaction is 2Na plus 2OH minus gives rise to 2NaOH. The overall reaction is 2NaCl aqueous plus 2H2O liquid gives rise to H2 gas plus Cl2 gas plus 2NaOH aqueous. Thus, Cl2 gas is collected from anode compartment and H2 gas and NaOH aqueous are collected from the cathode compartment. Uses of chlorine as a disinfectant in water treatment for drinking purpose and in swimming pools. Number 2, in the synthesis of polyvinyl chloride, chlorofluorocarbons, and pesticides. Uses of hydrogen as a fuel and in fabrication of hydrogen-oxygen fuel cells, and in the synthesis of ammonia for fertilizers, and also in the hydrogenation of oils for making margarine. Now, uses of sodium hydroxide in degreasing metals, in synthesis of soaps and detergents, in making paper and artificial fibers. Now, let us discuss synthesis of bleaching powder, another chemical. Bleaching powder is produced by the action of chlorine gas on dry slaked lime CaOH twice. Bleaching powder is generally represented as CaOCl2. However, the actual formula is quite complex. The chemical reaction is CaOH twice plus Cl2 gas, CaOCl2 solid plus H2O. Uses of bleaching powder for bleaching cotton and linen in textile industry, for bleaching wood pulp in paper industry, for bleaching washed clothes in laundry, to kill germs in drinking water treatment. Now let us discuss synthesis of baking soda, that is sodium hydrogen carbonate. Sodium hydrogen carbonate is produced by the reaction between aqueous sodium chloride, carbon dioxide, and ammonia. The chemical reaction is NaCl plus H2O plus CO2 plus NH3 gives rise to NaHCO3 plus NH4Cl. And let us see the uses of baking soda. For making baking powder, which is a mixture of baking soda and a mild edible acid such as tartaric acid. It is also an ingredient in antacids to neutralize excess acid in the stomach. 3. In soda acid fire extinguishers. Now let us discuss synthesis of washing soda, sodium carbonate. Sodium carbonate, the formula being Na2CO3 10H2O, is produced by heating baking soda and then recrystallization of sodium carbonate. The chemical reaction is 2NaHCO3 upon heating produces Na2CO3 plus H2O plus CO2. Then when you recrystallize Na2CO3 in water, it gives us Na2CO3 10H2O. Uses of washing soda. It is used to remove permanent hardness of water. It is used in glass, soap and paper industries. It is also used to make borax, a chemical, and it is also used as a cleaning agent for domestic purposes. Then self-assessment test. First, let us see a few multiple choice questions. In the chloralkali process, which of the following is liberated at anode? A. Hydrogen, B. Chlorine, C. Sodium hydroxide, D. Hydrochloric acid, hydroxyl radical. Question 2. In the chloralkali process, which of the following is liberated at cathode? A. Hydrogen, B. Chlorine, C. Sodium metal, D. Hydroxyl radical. Question 3. Which of the following ions is allowed to flow across the ion selective membrane? A. Na plus, B. Cl minus, C. OH minus, D. H plus. Question 4. Which of the following is used as a disinfectant? A. Hydrogen, B. Sodium hydroxide, C. Washing soda, D. Chlorine. Then which of the following is used as a fuel? A. Chlorine, B. Sodium hydroxide, C. Hydrogen and D. Sodium carbonate. Question 6. Which of the following is used to remove permanent hardness of water? A. Chlorine, B. Sodium hydroxide, C. Sodium hydrogen carbonate, D. Sodium carbonate. Question 7. Which of the following is used in paper industry? A. Hydrogen, B. Sodium hydroxide, C. Sodium hydrogen carbonate, D. Chlorine. Question 8. Which of the following is used to kill germs in water? A. Hydrogen, B. Washing soda, C. Bleaching powder, D. Baking soda. Question 9. Which of the following is used as a baking agent? A. Chlorine, B. Sodium hydroxide, C. Sodium hydrogen carbonate, D. Sodium carbonate. Other questions. Write the electrochemical reactions at anode, cathode, and the overall cell reaction in the membrane cell electrolysis of higher concentration of aqueous NaCl. Question 2. Write the function of ion selective membrane. Question 3. Reduction of H2O molecules is the preferred reaction in comparison to the reduction of Na plus ions at cathode in the electrolysis of aqueous NaCl. Account for this fact. Question 4. Write the uses of hydrogen gas. Question 5. Write the uses of chlorine gas. Question 6. Write the uses of sodium hydroxide. Question 7. Explain the preparation of bleaching powder. Write the chemical reaction. Explain the preparation of baking soda. Write the chemical reaction. Question 9. Explain the preparation of washing soda. Write the chemical reaction. Question 10. Write the uses of bleaching powder. Question 11. Write the uses of baking soda and washing soda. Thank you very much.